Okay, we've been looking at the standard form y equals mx plus c for a straight line. That's the slope, of course, and this one's the intercept. But there's one kind of line that can't be represented by this format. If I draw my x and y coordinates here, if I have a straight line, I'll draw it in red. If I have a straight line that's purely vertical, the slope is kind of infinity, so that's kind of a bit problematical. And the intercept doesn't exist. No, because this line here is parallel to the y-axis, so you've got a problem. Usually that doesn't matter. Usually you're not really interested in this kind of special case, but there is one way around it, and I'll show you what it is now. I'll go back to black. What you do is you write down ax plus by equals c, and that's the case for any set of numbers. How does it relate to the regular equation? Well, I can go by equals minus ax plus c. That c is just this one here. That ax is positive on that side, so it's negative on that side. And I've got by on its own. A, b and c are just constants. They might be positive or negative, but they're constant. They don't fool around. They don't change. So y equals minus a over b x plus c over b, provided b is not equal to 0. Okay, so comparing it with the previous standard, mx plus c, we see that the slope is just minus a over b, because that's the thing that we multiply x by here, and c is what's called, confusingly enough, c over b in the new notation. So this is the old way and this is the new way. I say old and new as if the new way is some kind of new improved format, but it's not. Ax plus by equals c. We'll just fool around with that a little bit. I can get ax plus b. See that while I'm thinking about this, I'll just write out the equation again and again and again, just to get it familiar. I can say 2ax plus 2by equals 2c, just multiplying it by 2. And that's still a solution. So you can see that, in fact, I can multiply by any non-zero. I can multiply by 7. 7ax plus 7by equals 7c. So we can take a and b and c as the parameters for this, and that's the same line as 7a, 7b and 7c, because I can just multiply this equation by any number here, 7. And of course there's nothing special about 7. I can multiply it by any number I like. So we've got 3 parameters, but they're not kind of uniquely specified because I can scale them all. As long as I multiply them all by the same value, we're sweet. Ax plus by equals c. Let's just have a think about what that looks like. It's a nice simple format, because if I say x equals 0, what does that tell me? Well, that tells me that this term here drops out. So I've got by equals c, so y equals c over b. So x equals 0 means that y equals c over b. So if I draw so if I draw my x-axis and my y-axis here, and my straight line, which is going to look like that, remember we're doing the x equals 0 calculation, which corresponds to where does it cross this axis here, and that point there is the intercept here, which is c over b, which is there. And of course the other intercept is here. What's that one? Well, we've got ax plus by equals c, and now I want to set y equals 0, because we're interested in this axis here, and this axis is the set of positions for which y is equal to 0. So that means that this equation, this term here, drops out in the equation. So what we're left with, we've got ax plus by equals c, so now we've got ax equals c, and that tells me that x equals c over a. X equals c over a. So that's quite a nice way of thinking about the line. What else have we got? The other thing to notice about this line here is that the slope is negative. In this case, A and B and C are all positive. They're all greater than 0. But the slope is negative, and you can see that that's right, because when we did this this calculation here, we knew that the slope was actually minus A over B. Spoiled that. Minus A over B. Anyhow, there you go. There's an alternate formulation for the straight line. AX plus BY equals C. And we'll see in a later screencast, when I start talking about more advanced concepts like dot products and so forth, that this one's a very natural formulation for straight lines that allows you to generalize it to hyperplanes and all sorts of exciting stuff. Right, I'm going to stop there.